So today I'm going to talk to you about what you are going to be expected to do in your Lab 6, the Forces and Acceleration Lab. Basically, in this lab, we will be using a simulation, and we're going to be using Newton's laws and trying to figure out the acceleration of an object and whether that matches with what's Newton's laws of motion. So as you can see here, I have your lab open, and we have some information about how to calculate acceleration, and then we also have some ways of calculating what data files that you'll be filling in, your charts, and just the questions that you'll be answering in this lab. Now, in order to access the simulation, you can just control-click the Physics Aviary site, and it will open up to this page. Now, this page, you can see that there's a click that you just click to begin, and you're given this setup. Now, normally when we're in class, you would have a setup very similar to this. This is actually very close to what you would have experimentally in class. The difference is we don't use an index piece of paper. We use a different type of thing, but it's quite similar. So in this setup, they give you a length for this piece of paper. And this piece of paper is quite important. This is they're making it like an index card here. This index card is important because these 1 and 2 are photo gates. And how a photo gate works is that it has a laser that is picked up by the sensor on the other side. So there's a laser on one side that is going across the opening, and it hits a sensor. And when you block that sensor, it picks up the what time it is when it's blocked. And then when the laser is able to hit the sensor again, then it knows what time it started to make that connection. And so when you have this index card going through the photo gate, it is blocking the sensor, reading the amount of time it was blocked, and therefore filling in the timestamps here. Okay, so the time when it was first blocked to the time when it was unblocked. So some things before I run the simulation so you see what I am talking about. We also have a way to change masses. So if you click on the masses, you can change the puck. They call it a hover puck on the top of the board. The reason why this is hover is because we're assuming this is a frictionless system. Note, this is a simulation. It is not perfect. One nice thing about doing this in real person is you actually do have effects of friction, and simulations are meant to be perfect. They don't have that nice error. So you can increase and you can decrease the weight. You can also change the hanging mass, and so you can increase or you can decrease and see what happens. And then you return to your screen. Okay. When you're ready to start your experiment, you have to press this green button for play. Okay. You still have to press start, but this basically is setting everything. You have all your masses set. It sets all the criteria that you're which you're facing. Now you're going to press start, and when you do that, you're going to notice how the puck moves across and how the hanging mass goes down. Now when this happens, you'll notice that we get several times here. When it was going through the first photo gate, you had the time where it entered, which they call state 1, where it's basically closed. And then when state 2, so the second thing, you have what they call 0, which is basically it's open again. So you've now got the laser reconnected. So this is the amount of time that index card was in that photo gate. And the same thing for photo gate 2. We have the time. So in your lab write-up, you will discover that you have the T1 and the T2, T3 and the T4. This corresponds for the time entering, the time leaving, and then the 3-4 is for the second photo gate, time entering and time leaving. What the T2 minus T1 means is that you're looking for that difference in time, because that tells you how long that index card was in that photo gate. Now, What's very important also is knowing your time between your photo gates. Now this big T value here that you see, that is actually corresponding to the time between the gates. So you know the time that was that this index card was in the photo gate, the length of time. You also know the time that it came into the photo gate and the time that it left the photo gate. So these times are very important to see what's the time between these gates. So this is a question for yourself that you should ask yourself, is which time, if we're looking at the time between photo gate 1 and 2, which times do we want to use? Do we want to use the time that they enter, the difference in the time between when they entered into the photo gate, the difference between the time that they left their photo gates, or the difference between the average time in each photo gate? And so that is up to you. Now, one thing I will note is that when we're looking at studying the time between these photo gates, you don't want to find the time when it left the photo gate to the time where it entered the next photo gate. That difference of time will be way too short in order to make the proper analysis. That leaves off the fact that we're not keeping these states consistent. We need to make sure that we're finding the difference of the same state. So the state of it either entering both the photo gates, the state of it leaving both photo gates, or the state of the average time that it had between the photo gates. So that's what that big T 1, 2 is. Now, as you see here, the time that it enters into the photo gate, the time it left its photo gate, and you also know the distance that it traveled during that motion. So when you get these values, you are calculating instant velocity in that photo gate. Yes, it's the average velocity in photo gate 1, but we're looking at it as a snapshot in this motion. So it went through photo gate 1 and photo gate 2, and we're going to take that value, that average velocity through photo gate 1, and take that as the instantaneous velocity for photo gate 1. And the same thing for photo gate 2. We take that average velocity of photo gate 2 and we make it the instantaneous velocity of photo gate 2. When that happens, you can then calculate acceleration, because now you know your velocity, your instantaneous velocity in 1 and your instantaneous velocity at 2. And you know your time difference, the time that it took to go from photo gate 1 to photo gate 2. And you can calculate your acceleration. From there, you can actually solve your acceleration. You can increase the mass of the car, you can increase the hanging mass, and see how that changes the acceleration of the object. So then you're going to use this acceleration and you're going to apply it to Newton's laws, and you're going to solve for tension. And you're going to solve for tension that the hanging mass experiences and the tension that the hover puck is experiencing it. And so that's why you have these two parts, the first part and the second part, because one is dealing with the cart or the hover puck, and the second one is dealing with the hanging mass. And so from solving that, you should discover that those tensions should be comparable and very close in value. Good luck with your lab.